C, we'll take a look at the principle of angular momentum by looking at a rotating sprinkler head. In this problem, your control volume is the full circle that encompasses both nozzles of the sprinkler head. Your coordinate system will be a radial one, with the radial direction pointing out along the arm and the theta direction being the angle along which it's rotating. This is vector notation for the absolute, the relative, and the control volume velocity. U is the velocity of the nozzle. W is the velocity of the water jet relative to the nozzle. And V is the absolute velocity seen of the water as it leaves the jet. Because we know in this case that U is just equal to negative angular velocity times the radius of the sprinkler, and because we also know that all V and W are in the theta direction, we can set up this equation here. In the first part of this lab, you'll work through this problem with other steps as well to try to give you an idea of V, W, and U. For the lab component, you're going to use a stroboscope to measure the angular velocity of the sprinkler, shown here. To use the stroboscope, make sure that it's plugged in and flip on the power. It'll take a minute to warm up. You're going to adjust the rate at which it flashes using this knob as well as this fine-tuning knob. Set it to the lowest velocity at first. Fine-tune with this. Increase angular velocities. Don't start from a high one or you risk aliasing. Now, make sure the sprinkler is sitting in the bucket so that no leakage occurs. Attach a hose to this nozzle here so that water is flowing into the sprinkler. You will see it start to turn. Make sure it's a constant flow rate. Use the stroboscope to obtain the angular velocity. Adjust the knob until you see the sprinkler head sitting still. Then you'll know you've obtained the proper angular velocity. In the meantime, start your stopwatch at a certain weight. This is sitting on a scale over here, and you can find that here. Time how long it takes it to reach a new weight. This will give you the flow rate through the sprinkler. At the end, use the values you obtain to complete the calculations in the lab.